Good afternoon, everyone. Welcome to another Planetarium live stream. How's everybody doing today? Glad to have everyone joining us on this Tuesday. We're switching things up this month with a special edition live stream. Let's see, we've got a few folks watching already. Welcome, everybody. As everyone's gathering, I'll start with some introductions. For those of you who don't know, I am Patrick Hess, Planetarium Manager at Union Station. And today we will be doing a special deep dive into the brand new imagery that we just received from the James Webb Space Telescope. So if you are tuning in for the first time, welcome. We're very excited to have you. We stream once a month. And normally we do a live stream about what's been going on in the world of space and astronomy news, as well as a little star tour for the month. But today it is special because we have a lot of really awesome data and information to look at. If you're a returning watcher, thanks for joining us once again. This is our 84th live stream. And thank you to all of our supporters over the past 2+ years. Also, thank you to our supporting sponsor, MRI Global, for keeping these live streams and many of the programs at Union Station going. We're so happy to have your support. So for all of our returning and first-time watchers, this is, again, our 84th live stream. If you've missed any of our past streams, you can find them on our YouTube channel, youtube.com/KCPlanetarium. There's over 70 hours of content there with dozens of deep dive live streams into all sorts of interesting topics in space and astronomy. And then over the past year or so, we've been doing monthly live streams about what's been going on in the night sky and in space history. We're going to be skipping that this month, though. In August, we'll circle back around and cover the last couple months. But today, like I said, we're going to be diving into the James Webb Space Telescope. Now, this is a live stream. If you're watching on Tuesday, July 12th at 6 p.m. Central, then be sure to drop us a mention in the comments. Let us know where you're watching from, and we'd love to say hello. We've already have some people chiming into the comments. For example, Tammy saying, "Hi, Patrick. We're hoping to get to KC next week." And awesome, Tammy. Tammy is one of our longtime watchers and supporters. And if you come to Kansas City, definitely stop by the Planetarium so I can say hi. Rachel says, "Greetings from Lansing, Kansas. I'm definitely not trying to watch this and my kid's softball game at the same time." All right, I won't tell anybody if you won't. And we've got James and Donna who can't wait to see all about James Webb Space Telescope. So keep those comments coming, everyone. But we are going to dive right in and kick things off. Before we start, just a couple of housekeeping notes. We're going to briefly whiz through some updates about the planetarium. Just real quick, we are open right now during the summer, 7 days a week, and our current schedule has 2 brand new shows. We've got Legend of the Enchanted Reef, which is an animated ocean adventure, as well as Destination Solar System, which is a high-paced ride through our solar system. Both amazing shows for kids and adults. So come check those out. Those are available many times during the day. Like I said, we've got a full 7-day-a-week schedule, different shows on different days of the week. So check those out. Tickets are available. First shows are at 11 Monday through Friday, 10 on Saturdays, and 12 on Sundays. Also, real quick, I want to plug, we have an upcoming set of laser shows. Our first Saturday of the month laser show set is continuing with August 6th, which this coming month in August will feature Laser Girl Power. So we're repeating last year's August theme, and we've got a bunch of really awesome shows showcasing some rockin' female artists. We've got a Girl Power mixtape, which has a bunch of awesome tracks, which you can check out for yourself. The full set list is available there, but it's got all your favorites, some on this list and some not on this list. So check that out. Madonna, No Doubt, just to name a few. And then we've got Laser Beyonce, Laser Lizzo, a brand new show for this year, Laser Britney featuring NSYNC. You're not going to want to miss that one. And Laser Lady Gaga. So you can scan that QR code there, somewhere there. There it is. If you want to buy tickets in advance, those do sell out, and they're already starting to sell for next month's laser shows. So check those out. Again, August 6th, that evening, the first Saturday of the month, Laser Girl Power. All right, we're already getting more comments. We've got Linda checking in from St. Peter's. Thanks for watching, Linda. Dee Dee's on the plaza. Hope you talk about Webb. That is all we're going to talk about today. Today's a special deep dive stream all about the amazing data and imagery that the James Webb Space Telescope has already revealed to us. So stay tuned, Dee Dee. That's what we're going to be covering in just a minute. Misty's watching and says, "Hi, Patrick." Hi, Misty. Thanks for tuning in today. Heidi is saying hello from Joplin. Thanks for watching, Heidi. Timothy from downtown Kansas City. Me too, Tim. Thanks for watching. And we've got David from Greenwood and Trace saying, what's up, Patrick? Thanks so much for watching. I recognize that name, another one of our longtime watchers and supporters. We've got Ann as well, watching from downtown KC. Looking forward to hearing about Webb. Thank you, Ann. All right, keep those comments coming. I'm loving the energy, everybody. And if you have any questions throughout our stream, be sure to throw those in the comments section as well. But for now, we are going to jump in to our James Webb Space Telescope announcements. And today, actually starting last night, but mostly this morning, the first full-color images were revealed that have been captured by the James Webb Space Telescope. Now, if you have been following along, just a little bit of background about the James Webb Space Telescope. This telescope was launched at the tail end of last year, last December, and for the past 6 months, it's been slowly deploying and unfolding, and it was a really complicated process. We actually covered the Webb Space Telescope in depth in January after the launch during our January live stream. You can check that out, and we can post a link to that live stream again on our YouTube channel, youtube.com/KC Planetarium. But just a kind of a very brief overview of what's going on. Now, the James Webb Space Telescope is that next generation space telescope, a successor to the venerable Hubble Space Telescope, which has been gracing our skies for the past 30 years. But James Webb is a bit of an upgrade. So you can see to scale here. I'm going to hide myself. But there is a person, an average height person, next to the Hubble primary mirror, which is about a 6-foot tall mirror. But the James Webb Space Telescope is a segmented mirror using 18 different mirror segments that cover a much, much larger surface area, which means this telescope can capture even more light than ever before. And as you'll see soon, we have some amazing imagery that is quite a step up from the Hubble Space Telescope. The orbit of this telescope is unique as well. Hubble is orbiting around the Earth, but the James Webb Space Telescope is actually orbiting a point in space called the Lagrange point, which again we cover more in depth during the live stream from January. But just to cover it briefly, essentially, instead of orbiting the Earth, Webb is orbiting the Sun, and it's in sort of a loopy orbit so that it always gets sunlight. That is how it gets a lot of its electrical power. So it always wants to be in the sun, but it also has a sun shield that's blocking its instruments, which need to be very cold. And now, what exactly can the Webb telescope do? Well, it can look back in time, and that is really the primary mission for the James Webb Space Telescope, is to be sort of a visual time machine. The farther away we look, the farther back in time we look, because light from distant galaxies takes a long time to get to us. And if we look far enough away, we can look back in time to just about the beginning of our universe. So ground-based telescopes have been able to look back in time of billions of years, but the Hubble Space Telescope was able to look back in time to just a billion years before the entire universe began. But the James Webb Space Telescope is able to look back to only a few million years after the beginning of the universe. So Webb's primary mission is to study galaxies and even possibly the individual stars that were formed right after the beginning of our universe. Now, a secondary mission, which we'll talk about today when we look at some of the data that Webb has gathered, is to study exoplanets. We actually didn't know a lot about exoplanets when the Webb Space Telescope was being designed, but since then we've discovered a lot of exoplanets. So Webb has been tasked to learn about them, and one of the first pieces of data is about exoplanets. Jumping in back to our comment section. Again, this is a live stream, so let us know where you're watching from. Say hi and give us a question if you have one. Jordan's watching from a Mexican restaurant. Excellent, Jordan. I hope the queso is good. David says, cool, Webb, thumbs up. We've got Davies watching from Gallatin, Missouri. Thanks for tuning in. We've got Emily watching from down the hall. Thanks for watching, Emily. Hope she's giving Phoebe some scratches. And Vernal's saying, whatever happened to the Hubble Space Telescope? Times have changed. Don't worry, Vernal. Hubble's still out there, and it's still doing science. In fact, Hubble's mission will probably continue for many years, and we can combine data gathered by Hubble and Webb to learn even more about the universe. So Hubble's still out there. It's still doing its thing. Kelly's saying hello from Lenexa, Kansas. That's where I grew up. Thanks for watching, Kelly. And we've got Lauren watching from New Smyrna Beach. Thanks for tuning in. Hope the weather is nice down there and the sand is warm. Got Heidi asking a question. Can the Webb focus in on specific planets from other solar systems? That's a great question, Heidi. And I think it's a question we're going to answer in just a minute. But we're going to jump right in. No more delays. Let's see the first image. This was revealed last night, actually, during a presidential press conference at the White House. and the first image revealed by the Hubble Space Telescope, or by the Webb Space Telescope. I'm going to have to rewire my brain there. By Webb was a object called SMACS 0723, which is a fun name. But this image has been renamed Webb's first deep field. Now, a deep field image taken by a telescope is one where we zoom in really far to just a tiny little fraction of the night sky. And it looks like nothing's there, but we open the aperture, we take a picture, and we kind of let light gather for a long period of time to see distant galaxies and stars that were originally hidden from sight. So this is Webb's first deep field. Now, this was previously imaged by the Hubble Space Telescope as part of the Southern Massive Cluster Survey, which is where SMACS comes from. And it's in the constellation Volans, which is in the southern sky. That is the Flying Fish constellation. Fun thing there. By the way, we did a live stream about the southern hemisphere, all looking at stars and constellations down there in the south. If you want to check that out, that was quite a while ago, all the way July 27th, 2020, almost 2 years ago. You can find that on our YouTube channel, youtube.com/KC Planetarium. So let's take a look at just how zoomed in this image is. There's already a bunch of really fun graphics that have been produced by people, and this is loading in. But to give an idea of how small this image was, you can imagine putting a grain of sand on the tip of your finger and holding it at arm's length, and that size that you can see from your vision all the way to the tip of your finger on that grain of sand is how zoomed in we are. So this is a view of our night sky, but if we zoom in, we can see just how tiny of a fraction of the night sky that image was. So there it is. So let's get a closer look at this picture. Well, that's pretty close, I think. So this is the deepest and sharpest infrared image of the distant universe that we've ever taken before. Now, I say infrared. This is primarily an infrared telescope, the James Webb Space Telescope, and the reason for that is because when we look far away, we are looking at galaxies that are not only really far away from us, but are also moving away from us. The universe is expanding due to dark energy, and so when we look at things far away, there's a Doppler effect. If you've ever heard an ambulance driving by you, the sound it'll make starts high, but then it kind of goes low as it passes you. It goes wee woo wee woo wee woo wee woo, and then as it passes you, you hear it go down wee woo wee woo wee woo wee woo wee. That is called the Doppler effect, and anything that travels in waves exhibits this effect: sound waves and light waves. So as the universe expands, distant galaxies are traveling away from us at faster and faster speeds, and so we need a telescope that's able to look at a light that is just outside of our range of vision, infrared light. That's redder than red light. And scientists are able to take those images, that data, and shift it to a visible scale. So some people ask if these pictures are real or if this is the real light, and it is. It's just shifted to a spectrum that human eyes can see. So it's all real science. So this is just a tiny sliver of our night sky, about 2.4 arc minutes across. If you want to be sciencey about it, that's about 1/13 the visual diameter of the moon. And here it is. So what are we looking at here? Now, this is a galaxy cluster. There are thousands, not just one galaxy cluster, rather. This is just a picture of masses of galaxies. There are thousands of galaxies in this photo, and some of these are the faintest objects we've ever observed in astronomy. And another cool thing is that there are some galaxies that are closer to us. This yellow blob in the center is one of the closer objects in this picture. And that yellow blob is so heavy that it's also causing gravitational lensing. If you kind of lean back and squint a little bit, you can see sort of round streaks on this photo, right? These are actually galaxies that are sort of distorted visually, kind of like a cosmic mirage, where this yellow galaxy in front of them is so heavy that its gravity is bending the light from these more distant galaxies. So we're seeing gravitational lensing here as well. So there's so much going on in this. Now this deep field photograph was taken by Webb's near-infrared camera, or NIRCam. Webb has a lot of different instruments that it can use to image different wavelengths of light. And this composite image was made from images that were taken at a bunch of different wavelengths, totaling about 12.5 hours of exposure. So when you take a picture of a dark, something dark, you might have to leave your exposure open. If you have a recent phone with a night mode, you've probably noticed how when you take a picture, it tells you to hold still for a while it's developing. Well, imagine taking that picture and holding still for 12.5 hours. That's what Webb did. Now, this achieved depths of infrared wavelengths beyond what the Hubble Space Telescope's deep field could see. When Hubble took a picture of this same part of the night sky, it took weeks for it to actually gather this light. And we actually have a comparison. There's a really awesome, spoilers, there's a really awesome tool that somebody put together that allows us to compare different images taken by Webb and Hubble. So here is the Hubble Space Telescope's image of this same region of the sky. And we can see it's pretty dim and grainy and not a lot of detail and color. But if we wipe across here, we can see Webb's image of the same region. So you can still see the gravitational lensing, but there are hundreds, if not thousands, of more galaxies visible by Webb, not to mention just a higher amount of detail we can see. And if we zoomed in, we could almost see individual stars in these distant galaxies. Now, this is just the beginning, of course. Webb is able to take even longer exposures, so it's hard to even imagine what we'll be able to see if this is the first image. So this image, it shows this galaxy cluster as it appeared 4.5 billion years ago. And there are even more galaxies in front of and behind this cluster. And researchers were just starting to dig into this data that Webb has gathered. It's just incredible. It's hard to even really describe. Now, light from these galaxies took billions of years to reach us. We're actually looking back in time, like I mentioned before, to just hundreds of thousands of, or hundreds of millions of years after the Big Bang, when some of the youngest galaxies in our universe were formed. And so by studying these ancient galaxies, we'll learn more about the formation of galaxies and the origins of our universe. So I mentioned the gravitational lensing. Some people have described it as sort of a Salvador Dali painting of these galaxies being sort of stretched and warped out. Now, one thing I wanted to mention is in this image, and in many of the images you'll be seeing from Webb, there are these diffraction spikes, which are these sort of cross patterns. Now, these cross patterns are different from Hubble's. You'll see Hubble has just sort of a four-pronged spike here, but Webb's is interesting. It sort of has 8 prongs, and I kind of wanted to dive in a little bit about why that is. And there's a great graphic that NASA's put together. So it all has to do with the structure of the telescope, how it's built. So this is sort of a diagram of the Webb telescope, and we can see that it has multiple mirror parts. There's the main primary mirror, but then there's a secondary mirror to bounce the light into the instruments, and you can see these struts holding it up. And these struts have an interesting pattern, right? They've got this sort of triangle pattern. So we can see, again, the Hubble pattern of struts, which were more sort of boxy from the primary and secondary mirror, and then Webb's is a little bit different. And not to get into too much of this, but basically it all has to do with the geometry of these struts and how the light kind of refracts off of them. And so you can kind of see this diagram explains essentially how the light creates these spiky patterns. So there are actually 2 different sets of spikes happening. There's this 6-pronged spike, which is from the primary mirror, which is hexagon patterned. And then there is that sort of squat strut there, or the squat little spike that are kind of superimposed on top of each other. So that's what we're seeing there when we're seeing these spikes, and those are intentional. I should also mention that some objects have spikes and some don't. The ones that do have spikes are stars, and these are stars in our own galaxy, nearby to us. But then these other galaxies are so distant that they really don't even have their own spikes here. Some of them you can see very faintly, but the ones that have the brightest and most prominent ones, those are stars in our own galaxy. So much to talk about, and that's just the first image. We're going to be looking at 5 different images released by the Webb team. This is just the first one. There's other data besides these images. In addition to these images, the instruments also obtained spectra data, which reveals objects' physical and chemical properties. This will help researchers identify many more details about distant galaxies in this field. It's just incredible. There are, again, thousands of galaxies in here. The data from some of these galaxies is 13.1 billion years old, which is, again, just hundreds of millions of years after the beginning of our universe. So it is pretty incredible. And that's just the first image, so stay tuned. We are going to be looking at more of what Webb has already shown us. In the meantime, though, let's check into the comments section. Remember, this is a live stream, so if you have any comments or questions, pop those in. Mike and Michelle are watching from St. Joe. Thanks for tuning in, both of you. Betty is watching from Atchison. We've got Vernell asking, do we have any good news for Pluto since we exiled it? No good news other than Pluto's still out there doing cool stuff, and scientists are still studying imagery taken by the New Horizons probe that passed Pluto in 2015. But don't worry, if you want to learn more about Pluto, I actually did an entire hour-long show about Pluto on January 4th, 2021. Again, youtube.com/KC Planetarium has all of our past live streams, so if you want to learn more about Pluto, check out that stream there. Angela says, hello from Florida Space Coast. Thanks for watching, Angela. Say hello to the rockets for me. Got Janine saying from Northwest Kansas watching. Thanks for tuning in, Janine. And Heidi is asking, do any of these galaxies resemble ours? That's a great question, Heidi. And spoilers if we go back. There are different types of galaxies. These yellow blobby galaxies are elliptical galaxies, which are typically older galaxies. But then we do see some spiral galaxies that are similar to the Milky Way. So there are some galaxies that are like ours. And Teresa says, how long will Webb provide images? Great question, Teresa. Unlike Hubble, Webb has a sort of a limited lifespan. Hubble is solar powered and it's orbiting the Earth in a pretty stable orbit, so it will probably last a while longer. But Webb is in an orbit that requires it to kind of correct itself, so it won't stay in its orbit perfectly. You can kind of imagine trying to balance something on the tip of your finger. You have to kind of move around to keep it balanced, right? Well, Webb does that too. Now, the good news is that originally astronomers and scientists and engineers were a bit conservative with their estimations. They planned on Webb's mission only lasting 10 years. But Webb's launch was so successful that it has enough fuel to likely last about 20 years and perhaps even longer. So we have decades of science left, Teresa, so don't worry about that. Casey saying, I'm freaking out. How gorgeous James Webb first photos are. Well worth the wait. That's right, Casey. And I'm glad you're sticking around because there is even more to come. I wanted to show, this is just some of the spectral data gathered from that image, and you can see one galaxy here that is 13.1 billion years old. Again, just hundreds of millions of years after the beginning of our universe. Pretty incredible. And so we can actually see the chemical composition of these distant galaxies. We can see some galaxies are forming new stars, or were billions of years ago, and some are older with aging stars. All right, everyone, we're going to jump on to the second piece of data. And the second piece of data is not really a picture, but something still very cool. This is data that is showing us the atmospheric composition of an exoplanet. So an exoplanet is a planet in a distant star system. We covered exoplanets quite a while ago during our Earth and Exoplanets live stream on February 8th, 2021. But just to be brief about it again, exoplanets, distant planets around distant stars. And this exoplanet is named WASP 96b, which WASP stands for, what does it stand for? Wide something something. Basically, it's an acronym talking about the probably either the telescope or the survey that discovered this exoplanet. But this is a gas giant planet about half the size of Jupiter, and it is 1,120 light years away from Earth, over 1,000 light years away from us. And it orbits its parent star about every 3.5 days, so that's incredibly close to the star. So its year is 3.5 days long. Now, what we're seeing here is the atmospheric composition of this exoplanet. So the James Webb Space Telescope, as amazing as it is, it can't take a direct picture of this planet because the planet is too small and its parent star is too bright. But it can observe a transit as this planet passes in front of its parent star, and it can measure the chemical composition of the planet's atmosphere. So you essentially observe the star when the planet isn't transiting and then subtract the difference. I've got a little diagram showing how this works. So the planet is passing in front of its parent star, and as the planet passes in front of it, the light kind of cuts through its atmosphere, and then the James Webb Space Telescope is able to detect the how the light bounces off molecules in the atmosphere of this planet 1,000 light years away, which is incredible. Now, the most exciting part is that in this spectral analysis, we found water. So we have detected water on a planet that is 1,000 light years away, which is pretty incredible. Now, some other things about this planet. This planet was specifically chosen because it was thought to have fewer clouds that dominate the signal of these chemicals. So it's easier to get a strong signal, more detail basically, so the clouds don't block it. And this signal is showing us water vapor in its atmosphere. So this is incredibly exciting. Now, it should be noted that because this planet is so close to its parent star, that this is most likely water vapor. There are no oceans on this planet, most likely. In fact, we can use Space Engine to actually visit this planet, which I've already got it queued up here. And well, you can see it's kind of glowing red hot. But again, we know that there is water molecules in this planet's atmosphere. So again, this is to scale. This is the size of the planet relative to how close it is to its star, which is very close. And we can see it is very hot. But again, there is water. And this is just a great indication of what's to come. You know, once we start studying other exoplanets that aren't quite as hot, perhaps we'll find even more amazing chemical compositions in them. So again, this is a real exoplanet. This is actually where it is. It was discovered in 2014, there it is. This actual exoplanet that we were able to capture data from in its atmosphere. So a little bit about exoplanets. Let's load this up. There are currently 5,054 confirmed exoplanets that have been discovered to this day. NASA has this amazing dashboard here telling us all about it. They're from 3,789 different planetary systems. 391 of these planets are within 100 light years of Earth. So if we could travel at the speed of light, you'd be able to visit them in your lifetime. And 84 of these planets have host stars that are visible to the naked eye. So you can actually look at a star in our night sky without binoculars or a telescope, and you can know that there is a planet around that star. There's also one exoplanet that we know of that is 4 light years away from us in the nearest star system, Alpha Centauri. So that exoplanet is in that triple star system. And if anybody's read the 3-Body Problem series, you may know about that exoplanet. I won't spoil anything, but it is a very famous one. And let's just say perhaps the James Webb Space Telescope will someday reveal whether or not that book series is potentially accurate. So this website is amazing. It shows us how different exoplanets are discovered. So most of them are discovered via transit transit spectrometry or spectroscopy, I think is the right word. But there are other ways to discover exoplanets. You can actually look at the wobbliness of stars, because as planets go around stars, they actually pull on them a little bit, and we can measure that wobble. You can use gravitational microlensing, so stars will actually bend starlight, and we can actually measure that gravitational fluctuation. And then we can actually directly image a few exoplanets. So there's some that are detected just by taking photographs, which is incredible. So again, not a photograph, but still pretty incredible that we are already able to study the chemical composition of the atmosphere of a planet 1,000 light years away by this telescope. So who knows what's going to happen when we study even more exoplanets. All right, that's the second piece of data. Let's jump back into the comments. We've got Todd watching from Blue Springs. Thanks for watching, Todd. Hope you're enjoying tonight's stream. Janine is watching from Phillipsburg, Kansas. Jesse says hello from KCMO. Jesse watched the stream on the European Space Agency's website this morning. It was everything I had imagined it would be and more. Hashtag science rules. Absolutely, Jesse. So yeah, this morning, NASA and the European Space Agency, who are working together on the Webb Space Telescope, they had live streams talking about these images in depth, and you can find recordings of those if you want to dive in and actually hear from the scientists themselves all about them. But I'm honored that you're here tonight with me to listen to what I have to say about it, of course. Casey says, comparing Hubble's photo to Webb is like wearing prescription glasses for the first time. Absolutely, Casey. That's a great way of putting it, and we're going to look at even more of those comparisons coming up soon. And Rachel is working on the three-body problem now after your recommendation. That's awesome, Rachel. Cool. Well, I hope you enjoyed that book series. They're all amazing. The second one, I think, is my favorite. But be prepared to have your mind blown in some amazing ways. And someday, maybe I should do a live stream just for fun someday about the three-body problem, because it's one of my favorite book series. And there's a lot of good astronomy happening in that series. All right. Back to it. Let's look at the third of 5 images revealed, and this is a picture, so get ready, put those socks on so they can be knocked off once again. And this is a photograph of the Southern Ring Nebula. Actually, there are 2 photographs, and we'll talk about the different images and what they are telling us. So this is a planetary nebula, cataloged as NGC 3132. It's also nicknamed the 8-burst nebula, which I couldn't find information about why, but there you go. It's about 2,500 light years away, and it's in the constellation Vela. And now, planetary nebulas have nothing to do with planets. What we're looking at here is the remnants of a dead star. This is sort of the shell of an ancient star that died and spread its layers, it shed its layers over the course of thousands of years, and this is the leftovers of this dead star. Now, there were 2 different instruments on Webb that captured this series of images, and I actually put together a little diagram using Photoshop here. We can look at these 2 images. We can fade between them. So the stars and their layers of light are prominent in these images from the NIRCam, the near infrared camera, which is this image here. So again, we can see the stars and sort of the structure of this nebula. But the images from the mid-infrared instrument, which is the other imagery here, let's do this. We can fade in there. There it is. This is showing us, this is actually peering through the dust in this nebula and showing us the secondary star at the center of this nebula. For the first time ever. So before we couldn't actually see that there were 2 stars in the middle of this nebula, but now we can. The brighter star is in an earlier stage of its evolution and will probably turn into its own planetary nebula in the future. And the dimmer one is the ancient star that its leftovers we can see as the planetary nebula here. So again, fading to these 2 different images showing the same feature, but just in different wavelengths and revealing different details. So the brighter star here influences the nebula's appearance. The pair of stars continue to orbit one another, and they sort of stir the pot of gas and dust, causing these asymmetrical patterns. Let's hide that out of the way. Each shell, each layer of these different colors represent different episodes where the fainter star, the older star, lost some of its mass as it was dying. So the widest shells of gas towards the outer areas of the image were ejected earlier. These are ionized hydrogen typically. And then closest to the star are the more recent gases like helium and sort of that bluish color. We can trace these ejections, which allows researchers to look into the history of this star system. Now, prior to this image, there were a lot of questions out there about how planetary nebula form and why they were often asymmetrical in these weird shapes. And one theory was that it could be a binary companion star that causes these detailed structures. And this photograph kind of leads us towards accepting that that theory may be the reason why these nebulas aren't sort of perfect, even shapes. So seeing this second star is pretty incredible to start to confirm these theories that we've had for decades. So these images also reveal extremely fine rays of light around this nebula. And let's go back to our comparison site here. And of course, there is a comparison. Now, this is really incredible. This image was taken in 1998 by the Hubble Space Telescope. So near the beginning of Hubble's lifespan. And it's a pretty incredible photo in and of itself, honestly. But, well, you can see where that upgrade was. So much more detail. We can see its outer layers in much brighter light. You know, like one of our previous commenters said, it's like getting prescription glasses for the first time. Pretty incredible. So this gas and dust will eventually enrich the areas of space around it, and it will expand into what's known as the interstellar medium. And eventually this gas and dust may coalesce once again through the force of gravity to form new stars and planets. So this cycle of death and rebirth is how stars are born. So pretty incredible stuff. Again, the Southern Ring Nebula. All right. Looks like we don't have any comments or questions. Hope everybody is still enjoying tonight's stream. And we are going to continue on. Oh, actually, we do have a comment here from Misty saying, is this nebula named the Eye of God? I think I saw it in one of my books and just wanted to be sure. That's a good question, Misty. And that is actually a different nebula. The one you're referring to is the Helix Nebula, which is a different nebula. It looks very similar. It is also a planetary nebula, but the Helix Nebula is a slightly different, but it is the same type of nebula. So good eye, Misty, definitely you caught that comparison that they were the same type of nebula. All right, let's move right along before I totally lose my voice. Let's look at the fourth of 5 images that the Webb Space Telescope team revealed, and this is Stephan's Quintet. This is very, very cool. This was the first compact galaxy group ever discovered. It was actually discovered all the way back by Edouard Stephan in 1877. And it's located in the constellation of Pegasus, which is actually a constellation visible around midnight this season. Kind of a funny story about this constellation, or this deep space object, is that it was featured in the classic film It's a Wonderful Life. So when the angels are talking to each other and deciding that Clarence needs to go down to Earth to help George Bailey, these are the galaxies in Stephan's Quintet. Obviously, this is some early imagery before we had the Hubble Space Telescope, probably from a ground-based telescope. It's a slightly different orientation, but you can see there's been a bit of improvement since the 50s. Again, just kind of funny. This is the It's a Wonderful Life galaxy group. So now this is called a quintet, and there are 5 galaxies sort of in this picture. But it should be mentioned that the leftmost galaxy, this one right here, which is called NGC 7320, is well in the foreground compared to the other ones. So this galaxy here is about 40 million light years away, while these other 4 galaxies, sort of lined up vertically, are about 290 million light years away. So quite a bit farther and quite a bit bigger by comparison, since they're farther away but are about the same width. In the same way that the moon is about the same apparent diameter as the sun, even though the moon is much smaller than the sun. The moon's a lot closer. Now that galaxy, although it's 40 million light years away, is still pretty close in cosmic terms, and even the 290 million light year away galaxies are still pretty close compared to the billions of light years away that Webb is able to see. These relatively nearby galaxies, studying them helps scientists understand structures seen in the much more distant universe. So we can look at these close galaxies and learn about the distant universe much more easily. So this is an enormous mosaic. It's Webb's largest image to date. Covers about 1/5 of the moon's angular diameter, and it contains over 150 million pixels and constructed from almost 1,000 separate image files. So that took a lot of work by the Webb team. This again, Webb's primary mission is to study galaxies, and studying images like this will inform scientists about how galactic interactions may have driven galaxy evolution in the early universe. These galaxies are interacting with each other. These 4 galaxies are kind of in the process of crashing into one another. We can see sparkling clusters of millions of young stars and starburst regions in these redder portions where new stars are being born. And we also can see tails of gas and dust getting pulled from one galaxy to another due to gravity. There's also a giant shock wave. This sort of red streak right here is a shock wave that is being created by the 2 galaxies colliding, and it's creating new stars. So as these galaxies crash into one another, the gas and dust get smushed together, creating new stars. And we are watching this play out in just this dramatic fashion from the Webb Space Telescope. It's pretty incredible. And this particular galaxy cluster is going to be providing data for months and years, and will allow scientists to continue to study the fundamental nature of galaxies. Now, tight groups like this may have been a lot more common in the early universe, when their superheated infalling material could have fueled very energetic black holes called quasars. And actually, the topmost galaxy here has an active galactic nucleus. It has a supermassive black hole we know is there, about 24 million times as big as our sun. It's actively pulling in material and shooting out light energy equivalent to 40 billion suns. And we can see light jets from this black hole. And Webb is able to pierce through the shroud of gas and dust to reveal this energy created by this black hole. So we're able to study black holes with the Webb Space Telescope as well. Pretty incredible. And the coolest thing about this, I think, let's go back to our comparison. Yep, that one. So Hubble, of course, also took a picture of this, and Hubble's image is still pretty incredible, honestly, looking at it. But look at the darker patches, the darker space behind these galaxies. And as we compare over, we can see that not only are we able to study these galaxies in more detail, but with Webb, we can see behind the galaxies, and there are thousands of other galaxies previously hidden that are now revealed. So even just looking at the same thing that Hubble could see, we can see even more beyond Hubble. So pretty incredible. Again, Stefan's quintet. All right, so let's jump back into the comments. We've got Andrea and Hal watching from Fort Wayne, Indiana. Thanks for this informative presentation. Thank you both so much for tuning in. Hope you're enjoying it. Angela says, cool, It's a Wonderful Life quintet. Absolutely. So next time you watch It's a Wonderful Life during the holidays, you can know that that is actually a real galaxy cluster. Vernell says, are any of those galaxies in danger of colliding? Do they have gravitational pull? I think I kind of answered that question already, but I'll just reiterate again. These galaxies are actually in the process of colliding. All of them except for this one. This one is sort of separate. It's kind of in front of the other galaxies like this. But these four galaxies here are crashing into one another, and we can see the shock wave of that collision as this streak of red light here, and that shock wave is actually creating new stars. So as galaxies collide, they create new stars. Pretty incredible stuff. All right, so yep, It's a Wonderful Life. All right, everyone, so we are moving on to the final image released by the James Webb Space Telescope team today. Now don't forget, Webb will continue to do science, and probably every week or so NASA will be updating us with even more amazing images. In terms of how they choose these images, I should mention that there is a review process, and essentially anybody can submit a request for time using the telescope, essentially. Obviously, the request is reviewed by a board of astrophysicists who deem whether it's a good request, and they're probably going to listen to people in the academic fields more than your average person. But it's so amazing that this tool is actually is essentially totally open to anybody using it, and all the data will be freely published. All the data from the pictures you've seen today, and not just the pictures, but the actual number data and the individual pixel data and all that deep scientific information that gets shared with the international community. So it's pretty incredible that in this day and age, with so much conflict in the world, that scientists and astronomers can work together and share this amazing imagery and data that we're capturing about our universe. And Naomi in the comments says, how far away is the bright star-like object to the right of the colliding galaxies? So let's go back to the picture here. There we go. So that is a star there, and honestly, I couldn't tell you exactly what star that is. I could probably do some investigating and maybe try to figure it out, but essentially this star, all of these stars, like I mentioned before, all the bright objects that have these sort of 8-pronged spikes, these are stars in our own galaxy, or nearby to us. And so these stars are only hundreds or thousands of light years away, versus these galaxies, which are tens, if not hundreds of millions of light years away. So that the scale is kind of hard to imagine. But again, all these spiky ones, those are nearby stars. The ones without spikes, those are distant galaxies. So every single dot you see here in this picture is a galaxy. Every single one of these dots. In this one photograph, there are thousands, if not tens of thousands of galaxies, and each one of these galaxies contains hundreds of billions of stars. Our universe is kind of big. We've got M saying, so the thousands of galaxies in these images, are they similar to the size of our galaxy? Some of them are, some of them aren't. So some of these galaxies are spiral galaxies like our own. This galaxy here is spiral in shape, but some are elliptical galaxies that tend to be much larger, these yellowy blobby galaxies. And some are irregular galaxies. Galaxies, as they're merging, form all sorts of different shapes. So we can see these sort of flat disk shapes. These are often spiral galaxies like the Milky Way. And they can be similar in size, if not bigger. For example, one of our neighbor spiral galaxies, the Andromeda Galaxy, is about twice as big as the Milky Way, even though it has a similar shape. But they're all relatively the same size. So we can see all these different types of galaxies, some that are similar to the Milky Way. All right, everyone, keep those comments coming, but we are going to be approaching the end of today's live stream soon. So if you have any last comments or questions, put those in. But for now, we are going to check out the final image that the James Webb Space Telescope team shared this morning, and that is an image of the Carina Nebula, specifically the Cosmic Cliffs region. So this is an incredible image, and they really saved the best for last. But this landscape of mountains and valleys, speckled with glittering stars, is the edge of a nearby young star-forming region called the Carina Nebula. It's about 7,000 light years away from us. And it was imaged by a couple different cameras, the NIRCam and the MIRI, mid-infrared instrument. And we'll see the different imagery in just a minute. But we're going to start with just this image. Now, this was captured in infrared light and again adjusted to visible light. But this image reveals for the first time previously invisible regions of star birth. And I'm just going to quickly jump over to our comparison to show you that Hubble took a somewhat close-up picture of this, and we can see these nebulas, these dark patches of gas obscuring the stars behind them. But we can see that Webb is able to peer through that gas to see the stars themselves being born. So let's actually pull up. I have the full resolution image loaded, and this is a gigantic image. But I just wanted to show you here that we can zoom in quite a ways, and just the amount of detail we can see here is incredible. In fact, this is all the way zoomed in, so you can see here. Oh, there we go. Just the sheer amount of detail that Webb is able to capture. So it's just really incredible. So incredible that you may be able to hear Phoebe in the background screaming about how excited she is. This is a region of a larger nebula called the Cosmic Cliffs. And this picture, seemingly three-dimensional, shows us all these peaks and valleys and mountains. Now, in reality, this is the edge of a giant gaseous cavity within the Carina Nebula, and the tallest peaks that you see here are about 7 light years high. So this is very, very big. The cavernous area we see here, if we zoom back out, not that far out. So we can see sort of this cavity carved in here. It was carved from the nebula by intense ultraviolet radiation and stellar winds from an extremely massive hot young star, or a set of stars that are located near the center of this bubble, which is in the area shown above. Now, this blistering radiation from these young stars is sculpting this nebula's wall, slowly eroding it away, carving it away, revealing these dramatic pillars towering above the glowing walls of gas. These giant regions here are that sort of resemble mountains are actually hot ionized gas and hot dust, which is streaming away from the nebula's intense, relentless radiation. So Webb is revealing deep inside these clouds of gas and dust stellar nurseries and individual stars that are hidden from visible light. So Webb's sensitivity to infrared light allows it to peer through that cosmic dust, which is why we can see things that Hubble could not. It can show us protostar jets, which emerge clearly in this image. And we can actually look at the different wavelengths. So this is taken by an even more infrared red amount of light, and we can see these red patches here are protostar regions. So areas of gas and dust that are starting to get pulled together by gravity, where stars are going to be born sometime in the near future. So as this cavity continues to erode, the starburst will propagate over time, and the gas and dust get slowly pushed away. As this gas continues to get pushed, it creates even more pressure, which forms more new stars and accelerates the star growth. It's just indescribable. I've said a lot about it, but sometimes you just kind of gotta let it wash over you. What we're looking at here, pretty incredible. So up to this point, scientists have had very little data about the influence of all of these young and energetic stars, the influence they have on nebulas like this. So Webb is going to be able to really start to understand the full impact and interactions between stars and nebulas and star birth. Let's go back to the other image here, and we'll just zoom back in. Just kind of pan around a little bit here. So pretty incredible stuff. Great desktop wallpaper background material. And NASA has released all of these images in their highest resolution. Again, you can download them, download all their data. Okay, Melody, so again, we're going to be wrapping up soon, and we've got a few more last-minute comments, so put your comments in now. We're going to be closing out the stream pretty soon in the next few minutes. Melody is asking, where exactly is Webb located again? Great question, Melody. The James Webb Space Telescope is located at a Lagrange point, which is sort of a gravitational eddy. You can imagine a stream that has rapids in it, and there are portions behind rocks where the water is kind of standing still. Well, the Lagrange point is a gravitational eddy, so a gravitational region in that stream where gravity is not really getting pulled one way or another. So essentially, Webb is orbiting sort of lined up away from the Earth and the Sun. So there's the Sun, the Earth, and then Webb is kind of outside the Earth. And Webb is actually orbiting the Sun, so Webb is kind of following the Earth as it goes around. And it's always visible in the sunlight. It's actually orbiting sort of in a circular loop. I had a little slide about that in my presentation, which I can go back to. There you can see L2, Lagrange point number 2, and Webb kind of looping around it there. Great question, Melody. Misty's asking, how many types of galaxies are there? And there are a bunch of different types and subtypes of galaxies, but there are, you can generally group them into 3 categories. There are spiral galaxies, elliptical galaxies, and irregular galaxies. Convenient, I know. The irregular galaxies are just kind of the everything else category. But there are different subtypes. There are barred spiral galaxies and non-barred spiral galaxies, different things like that. Casey says, this last photo is by far my favorite. It brought tears to my eyes. Absolutely, Casey. It is an incredible picture, and this is just the first day of imagery that Webb has shown us. Cynthia says, whoa. Couldn't put it better myself, Cynthia. Jesse says, again, tears and chills. The Carina Nebula is by far the best capture. I cannot wait for more images and info to be released. What a time to be alive. Absolutely. And shout outs to all the scientists and engineers who made this telescope possible. It's incredible. It's an incredible achievement that is literally decades in the making. And this is just the beginning. Now the Webb's all the way out there and doing its science. Who knows what amazing discoveries it's going to make. And Becca says, are the colors from the photo or enhanced? A great question, Becca. The colors are often real colors. Sometimes they are false color images. So when scientists capture data from distant objects, occasionally they'll sort of color in certain parts in certain colors to reveal structures and variations in their composition. But oftentimes they'll just take imagery that's captured in near visible wavelengths and adjust them to a visible wavelength. And that's what we're seeing here. Most of the James Webb Space Telescope's imagery or image sensors are designed to capture light in the infrared spectrum, which is a little bit past red that humans can't see. But we can use pretty simple techniques to adjust that data and imagery into a spectrum, kind of pushing it a little bit, just nudging it into the visible spectrum. And so that's what we're seeing here. So again, it's hard to really say if these are real colors. The images aren't of light that humans can see, but it is real light. It is real data. This is really what it looks like out there if our eyes could see infrared. It's just adjusted to a place that humans can see. Otavio's watching, says, go Patrick, go. Thanks for watching, Otavio. Appreciate you tuning in. Tammy says, how far are the stars away from the nebula? So about the Carina Nebula here, Tammy, this region here is about 7,600 light years away, the nebula itself, and there are stars in the foreground here in front of it. I'm not sure how distant those stars are, but they're probably a lot closer. But the stars that are being formed in this nebula are thousands and thousands of light years away. We've got Barb watching from Florida, says, love this. Thanks for watching, Barb. Hope you're enjoying the stream tonight. Jerry says, thank you. I hope to make it to the planetarium next week. Awesome, Jerry. Hopefully we'll see you there. Anne says, thank you for the very informative presentation. Casey says, I can't believe it's able to capture these images with only 12 and a half hours of exposure compared to the weeks with Hubble. Absolutely. So many more amazing pictures to come. I agree, Casey. It's incredible. And because it doesn't take so long to take these images, that just means even more science is going to be able to be gathered and amazing pictures revealed by Webb. Rhonda says, if these historic images of Carina, could stars be there now? Well, thank you for sharing your expertise with us. Rhonda, that's a great question. So these are pictures of a region of space, or a structure in space, a nebula 7,600 light years away. So that means it's taken 7,000 years for that light to reach us. Now, it does take hundreds of thousands, if not millions of years for stars to be born. So this nebula has likely not changed that much in the span of thousands of years. On the other hand, though, that's a good question, because other types of deep space objects like planetary nebulas, those do change quite a bit, as these stars are often, their deaths have often happened very recently. So we can actually take pictures over the course of years and watch the expansion of the gas inside a planetary nebula. Sometimes things do change a lot, sometimes they don't. And that's a great question. Angela says, thank you, Patrick, for presenting and explaining these images. Once again, awesome live stream. Thank you so much for watching, Angela. I hope you enjoyed the stream. I appreciate you tuning in, and I appreciate everybody watching tonight. We're going to start to wrap things up here, but thank you all so much. We are so excited to have these images and to see them. And we'll be showcasing more data and information about these images and other discoveries that Webb is going to show us at the planetarium. Don't forget, the planetarium is open 7 days a week during the summertime. So come visit us. Come see our live star tour, where we dive in depth to more astronomy and information about our universe. Come see our new shows, Legend of the Enchanted Reef and Destination Solar System. Brand new shows for the summer. And we have laser shows in August, Laser Girl Power coming up. One other plug, if you are a Union Station member, we have an exclusive member event happening tomorrow night. I'm going to be setting up a telescope on the roof of the parking garage by Union Station, and we'll be looking at the supermoon. Tomorrow's full moon is a supermoon, one of the 3 supermoons of the year, where the moon will be closest in its orbital elliptical path and full at the same time. So the moon will be about 15% bigger and 30% brighter. We'll be looking at it through the telescope. Again, this is a member-only benefit, so if you aren't a Union Station member, look into information about that. And you can get tickets if you are a member online right now. We'll be starting at 10 p.m. tomorrow night, again on the roof of the parking garage, looking at the moon through a telescope. And that about does it. Well, thank you all so much, everyone. One last comment from Will saying, missed you last weekend when you were at Union Station. Love these. No worries, Will. If you come by Union Station sometime in the future, I will definitely be there. And I will be here virtually for our next month's live stream, which will be on August 1st, the first Monday of that month. And we'll have a lot of ground to cover, because we will be covering what's gone on in the past 2 months of space and astronomy news, since we didn't do that today. So definitely tune in the first Monday of August, August 1st, where we'll be checking out what's up for the month of August in our night sky and in space and astronomy news. For now, though, I've been your planetarium manager, Patrick Hess. Thank you all so much for watching tonight, and thank you to our supporting sponsor, MRI Global, for supporting this program and many others at Union Station. And I hope you all have a wonderful rest of your month, and we will see you at the planetarium or under the night sky, and definitely under our virtual sky during our next live stream. So thank you all so much for tuning in. We will see you next time. Bye-bye.